Now we'll see pop. So first of all, we try to understand the idea behind, working principle of pop, how to implement pop. See, first see the picture and try to understand. So top is 3. First step what I want to do is I want to return this D to the callee. Example, someone calls pop like this, right? Like some arguments. When someone calls pop, then I am going to return. So in this pop, I am going to return this D. So here, whoever calls pop, they get D. For that, first step will be I take that D into a temporary variable. Let's say temp equal to this one. What is this? With respect to data array, that is data of dash top, correct? So data of top. First take the data. Second step, once you take the data, top should be updated to what? New recent element. What is that? C. For that, top should be decremented. So I do top equal to top minus 1. Later on, I return that temp. If I return temp, what happens? Then the to be deleted element will be returned. So simple, right? This is the core idea. So I am going to implement this. So we can do this thing, entire thing without temporary variable. We can do this entire thing in one line, you see. So what I write for that is simply data of, return data of top minus minus. What happens, you see. Why it works, I will tell you. So here top is attached with minus minus, right? Then top will be decremented, but it is post decrementation. We know that whenever we write post decrementation, immediately that will not take place. In the next line, it will generally take place. At this moment, first data of top will be taken. What is data of top? Data of, let's say top is 3, then data of 3 is D. So here, so first data of top will be taken, which is D, that will be returned. Later on, once this line is over, once we reach semicolon, in the next line, top will be decremented. When top is decremented, it will reach to what? 2. So same thing happening like this, correct or not? So finally, sophisticated code is this one, right? But both are correct. But we are writing it in one line. So why I am writing in one line? Because if you understand this kind of complex code, probably in GATE exam, if they give this kind of complex code, it will be easy for you. That's why sometimes some things are difficult, then don't quit them. Otherwise, don't skip them. Understand my point? So we have to learn difficult things. When you learn difficult things, then GATE will be easier for you and you get very good rank. Understand? That's why don't skip any part if you feel difficulty. So this part is now difficult part, we did it. Return data of top minus minus. But you can't access data and top directly. We have a pointer for that, correct? When you have pointer PS, we know that data is nothing but PS cap data. Let me replace it. Return data is PS cap data of top minus minus. What is top? Top is nothing but for us PS cap top. That's it. PS cap top of minus minus. So here I would like to mention one point. Actually these braces are not required now. These braces, I can erase them. Why? Since same logic. Cap and minus minus, they are equal precedence operators. When you have equal precedence operators, the natural precedence rule says that left to right. That means left operator will be evaluated first. Then you will be evaluating PS cap top. You will be taking PS cap top. After that we are decrementing it. So if you put braces also, same thing is going to happen. That's why, so you don't require brace because even natural order also same, correct? So this is the final return thing. If you do return PS cap data of this thing, then automatically data will be deleted and top will be updated and everything will happen. So that is what I have implemented here. Okay, let's see that. If C stack empty of PS, I pass PS, already PS is holding this address of this structure, isn't it? Then when you pass PS to that E stack empty already we implemented in such a way that that will return true or false based on stack empty or not. Really E stack empty is true, then stack will be empty, correct? Then E stack empty returns as 1. Okay, now return value of E stack empty is 1, then condition will become true. Here I want to tell you one point. So if condition works with values also. Okay, so whenever you have integer value or any value, that value is 0, then condition will become false. If that value is non-zero, like example minus 5, example E stack empty returns minus 5, then still if condition will become true. Remember one thing, in the place of expression, if you have value, then non-zero will be, if non-zero will be true, okay. Now if 0 will be false. Whenever stack is empty, then we have written 1. Did you remember that? That's why this condition will become, this e stack empty will return 1. Then if 1 is what? If non-zero is true, then if 1 is true, then this will happen. Sir, why are you taking underflow? So whenever stack is empty, then we say that is underflow. That means, stack doesn't have space to, otherwise stack doesn't have an element to delete. Still, if you try to delete, then we say that is called underflow. So what I'm going to do is, whenever you get such kind of situation, then don't quit the program, do some remedy. That means, example, really your stack is empty, but still some user mistakenly tried to delete an element. Then what should happen? Generally we should take some precautions. You have to send some text to user that, my dear user, this is not the time to delete. So such kind of things we can do if we know that they perform this kind of operations. Example, already stack is empty, still someone call pop, then what we do is we make underflow 1. Okay, now I will tell you how to use underflow. So, and we'll simply return. Once we return, then what we write? We write extra code. So what is that extra code? Is that extra code will examine underflow. Okay, if that underflow becomes 1, then that extra code will take care of that remaining error control. That means it may give a warning to user that, my dear user, when stack is empty, don't try to attempt that kind of things. Otherwise, some depends on the application, we do the precautions. Now else, if really stack is not empty, happy, what we do? We do return pscap data of pscap top. This is minus minus. So we decrement the top. But before that, we get the data. Understand? So here we have written sophisticated code. This code will delete the data at the same time when stack is empty. So it is not quitting. That means it is not giving up. Still it works. That means we are also doing error control. Otherwise I can say exception handling. Understand? In push we have written that error control thing, and in pop also we have written this error control. That means our program is designed such a way that if stack is full, still people try to push some data, still we have a model. That means somehow we do something so that you can add the data. Correct? Now if stack is empty, we have written a code such a way that underflow variable will become 1, and user can write some extra code such a way that still we can handle that kind of situations. So but basic methods, generally there are some basic methods. People generally implement basic methods in academics. What they do is, if stack is empty, then simply they exit. That kind of models are not good. What happens if whenever stack is empty, if I exit? See this situation. So what they do is, rather than doing underflow and all, if I do exit of 1, that means if I exit the program, then what happens? Your program is vulnerable. That means that is easily can be spoiled. Correct? That means a user, if delete some data when stack is empty, you are quitting the program. So that's not good idea. Somehow you have to handle the unexpected situations. That is what we are doing through underflow variable. That's why we are communicating to the other part of the program using underflow. Underflow says that something unexpected has happened. Similarly, overflow also says same thing. Understand? These are all the implementations of, otherwise these are all the I can say that implementations of the stack methods. Now we'll see the time complexity of stack push and stack pop. Let me start with pop operation. What is the time complexity of this pop? Okay, we'll see same technique. First line, e stack empty is a method. Correct? How much time it took? Recall. E stack empty took some constant time. Let me note down. Okay, now here I am noting down. First, e stack empty takes constant time. Let me add it. So what is the execution sequence? First we come here. Because of this one, since e stack empty takes constant time, then if line takes constant time. Done. Now I have calculated the time complexity of if line. Then control comes where? If really if condition is false. If condition is true, then program will be terminated after assignment, this underflow and return. Correct? After all, there are 2 lines. Okay. Case number 1. What is case number 1? If stack is really empty, then condition will become true after constant time and will come in inside this if condition, and underflow will become 1. How much time it will take? Constant. And return takes how much time? Already I told you, constant. Constant plus constant plus constant is constant. Case number 2, it is one more case where if condition is false. If condition is false, but to know whether if condition true or false, we have to evaluate that method, right? Then what is that method's time complexity? Constant. Okay, after constant time, if condition will become false. Then control comes to this one. In that you have some operations. This statement is nothing but there are some 3 basic operations. Already we know that. What are they? Decrementing top, accessing data at top, and returning it. They all take constant time, isn't it? Simply decrementing top takes constant time. Accessing the data in array takes constant time. Correct or not? Because array supports dynamic access. This point I would like to tell you. Example, you have an array and you want to access some position like a of 4. Time complexity of accessing a of 4 is not 4 units. Okay, because directly we'll go to a of 4. In array topic already I told you how your compiler generates memory address for a of 4. Correct? So there is a formula. Using that formula, so your compiler generates memory address and directly it will go and fetch the data. That's why I can say that accessing the array takes constant time, whatever the array location. That's why here you are accessing the data, it takes constant, decrementing top takes constant, and returning the data to the pop takes constant. So 3 constants again constant. Finally it will become constant plus constant plus constant. Understand my point? So finally 3 constants. 3 constant is nothing but constant. Here I write constant for if condition. After that here returning constant, accessing array constant, decrementing top constant. I can say overall constant. Constant plus constant, constant. Finally in any case, so you are taking after all constant time. That's why pop time complexity in stack is constant. In the same way, because push also is having same kind of syntax, right, and same kind of operations. That's why push time complexity also order of 1. Easily we can check it. Now finally you realize that E stack empty takes order of 1. We have seen E stack full takes order of 1 time. Yes, we know that. Now apart from that, push and pop also takes order of 1 time. Remember them. Okay. In stack finally all these basic operations takes only order of 1. Such a implementation we have. I am not saying that whatever the way you implement they take this time. I have an implementation. Agree? Yes, we have an implementation using array. That implementation is taking only order of 1 time for all the basic operations. So this is about implementation of the stack.